welcome to 60 minutes of unscripted .NET entertainment. As doctors of .NET, we prescribe healthy choices in .NET. I'm your host for this week, Cam Soper, with co-hosts David Pine and Luis Quintanilla. And we're here with today's guest, a returnee to the show, Vahid Farahmandian. Vahid, please introduce yourself and tell us a little bit about what you do.
Hello, good afternoon, good evening, and good night to everybody watching us. I'm Vahid, based on Tehran, the Chief Technology Officer of the Iran's largest maritime ERP. Tonight, we are here to talk about the building high-performance services with gRPC and Data5. I hope you enjoy it. So stay tuned with us tonight. Thank you.
Awesome. And again, we're really glad you're joining us again all the way from Iran. What time is it there right now?
It's 8:30 the evening PM.
Oh, okay. Well, thank you for
that. Yeah, that's awesome.
Thank you for giving up your evening to be with us. So we're talking about gRPC this week, and I think we have a checkup doc for that. So let's cue that up. All right, Dave, what do we got?
Thank you, Cam. So in correspondence with today's content from Vahid, we're going to talk about gRPC. So first of all, we've got an article that was put together. This is part of an ebook that is available. So our Architecture Center for .NET Docs contains many, many free ebooks. And as part of that, there's this cloud native communication patterns. And as part of that, there's gRPC. So what is gRPC? gRPC is a modern high-performance framework. It's based on remote procedure calls. It's from our friends at Google. And it's part of the CNCF, Cloud Native Computing Foundation. So there's plenty of benefits to this.
I just realized the document there, and I don't think we've mentioned it. What does the acronym stand for?
gRPC stands for Google, I believe, Remote Procedure Call.
Okay.
Since it's Google's, I believe, implementation of it. It's open source. So yeah, like I said, there's plenty of benefits to this. It's extremely performant. So when you think about like typical REST HTTP calls, most often you're dealing with serializing JSON or even XML. So gRPC is lightweight and highly performant. It's actually up to 8 times faster than JSON serialization, with messages being in binary, which is 60 to 80% smaller for payloads. So it's extremely efficient. And with that, behind the covers, we're talking about, protocol buffers, or protobuf for short. And with protobuf, it's basically taking your strongly typed C# objects and then defining the shapes of those. And it's similar to, I like to think of it as like attributes that you might add on a C# object that define like the JSON property, right? So this is very similar to that. You'll have like a .proto file that kind of signifies the shape of your strongly typed C# object that would sit alongside it. And then we've got obviously support for .NET. Otherwise, we wouldn't be talking about it today. There's various clients that are available for it. There's a full-on service template that we provide. And as I said, here's your protos. So you can see like greet.proto, and that would kind of detail the shape of your serialized object. And there's different scenarios. And this specific implementation here in this doc is signifying how the eShop on containers utilized it. So your mileage may vary. You might have different ways of doing this with your application and based on your needs. But yeah, hopefully you'll check it out. And I think that's about it for our coverage of gRPC in this doc. But I think we're going to dive in a lot more and have a bunch of things to talk about specifically from Vahid's hallway track session.
Yeah, I know Vahid was showing us before the show. He sent us a list of things he was going to talk about. So without any further ado, let's hop into our hallway track. Oh, Vahid, the floor is yours, man.
Okay. Thanks for David for the great links you provided. Is my screen shared already? It's okay. Okay.
Yep, we've got it up there now.
Okay, great. Tonight, I'm going to talk about the gRPC, specifically in the .5. First, I'll start with introduction to gRPC, then I'm going to talk about managing the portable preferences in the projects. Then I will talk about the deadlines and cancellations in gRPC and .5s and how we can define deadlines and how we can cancel long-running requests in gRPC and .5. Then I will talk about the authentication and authorizations mechanisms in gRPC and .5. I'll continue with the security considerations, gRPC, and then talk about transient fault handling, and finally talking about the testing gRPC services with gRPC URL. Of course, like many gRPC systems, or like many RPC systems, gRPC is based on the idea of defining services, specifying the methods that can be called remotely with their parameters and their return types. gRPC using a protobuf, as David showed us, uses the protobuf as the interface definition language or ideal to describe both the service interfaces and the structure of the payload and messagings. After the service definitions, gRPC has metadata, information about the particular RPC call in form of a key values, where keys are strings, values can be both strings or binary values. Of course, the metadata less clients provide information associated with the call to the server and vice versa. Beside the metadata, there is channels which provides a connection to gRPC server on a specified host and port. Clients can specify channels arguments to modify gRPC default behaviors such as messaging compression or etc. And also channels has states such as idle or connected, and it's really depends on the destination language. Some language supports the querying the channel's states, and some other does not support the channel states querying. And the final part is the communication patterns. gRPC supports 4 different communication patterns, such as unary, server streaming, client streaming, and bidirectional streaming, which we're going to talk about these communication patterns and works with them and see how they really interact with the server, and servers interacts with the clients. About the
so far, I just want to jump in real quick. So far, this sounds to me, and so I love it. We keep getting topics on the show that I haven't really played a whole lot with, so I get to like get introduced to stuff for the first time, and this is one of those times. Anyway, so this sounds to me like a lot like WCF. Like from where what you've started, you're like, okay, we have like service contracts, and we have all these different things that we can adjust there and define, and we can specify how the communication works, and it's all like kind of this upfront. We're gonna not imperatively but declaratively like define all of these behaviors.
The gRPC and WCF specifically has many in common. For example, in gRPC we have the bidirectional streaming, and in WCF we have full duplex communications. But the main benefits that we get from using gRPC is lightweight framework and lightweight communication mechanism, lightweight serialization, and the serializations benefit. It's really great for us, and it seems that migrating from WCF to gRPC does not need many efforts, as they have many in common, and just we need to solve some fundamental problems in a WCF. However, when we're talking about the WCF, we need to say that we have other frameworks for communicating between server and clients, such as I don't know, REST, such as GraphQL, such as WebSockets. All these frameworks and tools have their own strengths and weaknesses, and it's the requirements that tells us which one to use. We need to consider the costs and benefits and the requirements and make our decision to use which of these technologies. For example, I myself, when I'm going to talk about a human, or when human readability is the main problem for me, surely I choose the REST instead of using the gRPC. But when I'm going to implementing the interconnection between my microservices, of course, gRPC is a really great choice for me. Or when I'm going to provide a great adaptability for my end users, of course, I might think about the GraphQL. As a sum up, all these frameworks, all are great, all have their own strengths and weaknesses, and we should consider the requirements, the costs, and the benefits that we're looking and make our decision based on these three parameters. About the gRPC specifically, there is a protofile, as David again told us. As many RPC system, gRPC is based around the idea of defining services, specifying the methods that can be called remotely with their parameters and return types. It's really a simple clause, so then that's okay. On the server side, we have two different sides, the server side and the client side. On the server side, the server implements this interface and runs gRPC server to handle client's calls. On the client side, the client has a stop that provides the same methods as the server. If we take a look at the follow of the gRPC service implementations, at the first step, we define our proto, which consists of the message and the service. After defining the protofile, the proto-compiler plays its role. Proto-compiler compiles our proto to the destination language and provides the facilities to implement the server-side or the client-side codes. After proto steps, we need to implement the gRPC server or extend the gRPC server code to implement and build a server provider. When we have our server provider in place, the next steps, we need to go and implement our gRPC stub or the service consumer or the client side, extend the gRPC code to implement and build a service consumer. When the whole implementation is complete, the clients and servers are able to communicate with each other using the HTTP2 protocol, and they can talk to each other in a unary pattern or using the client streaming, server streaming, or bidirectional streaming. One of the main differences between the gRPC and WCF and REST and the other frameworks is the ability to use the HTTP2. This difference, we can consider it as a positive and a negative point for gRPC. Positive because HTTP2 is great and has a great performance, but negative from this side that some of the modern web browsers does not fully support the HTTP2 yet. So we might have a great and a clear definition and understandings of the environments, of the production environments, before we're going to implement our infrastructure using the gRPC. When we implement our gRPC framework, we need to know which pattern to use and which patterns, and to how to implement each pattern.
Sorry, to go back just a little bit there. You mentioned that step 2, you use this proto-C compiler, right, to compile these protofiles for any language that you choose. So in this case, we're talking, I presume, .NET, but what other languages could you implement these servers and client stubs? And could you mix and match? Like, for example, maybe your server might be using .NET and maybe your client might use something else.
About the language that are supported in this mechanism, by now the most of the most wanted languages are supported, such as I don't know, C#, the Go, and the other languages which are available in the gRPC.io. Most are supported to implement their gRPC. The good point here is that the gRPC server and gRPC stop can have their own language. I mean, the gRPC is completely language agnostic, and there's no essentials to implement the gRPC server and stops both in the same language. However, if we implement both these two, for example, in the .NET ecosystems, we can use the code-first approach to define the proto. I mean, we can write protofile, we can define our message and services, or we can write our C# classes, our like the WCF, our service contracts and data contracts, and then convert these C# classes to the protofiles. This feature only available if we use the both server and clients in the .NET mechanism, because when we're talking about this kind of architecture, we need to define a shared library between client and server, which we're going to talk about in the, I think, the next slides. So as a sum of the language that's supported, most of the most wanted languages currently are supported. The complete list of the supported languages are available in the gRPC.io website, but C#, Go, I think Python, all these are support the Proto and the gRPC currently, and they're going to, the other languages aren't their way to support the gRPC. However, if we want to get the great detailed information about this mechanism, we can go to the polarspark.com website. There's a great a paper published there, Introduction to gRPC. And we can follow that paper. It has a great information about the gRPC flows that we can read about them. About the communication patterns that I talked to you, the first one is the unary communication pattern, which is very similar to the REST request and response patterns. Where the client sends its request to server, gets the client sends its request to server gets the request, processes the request, and sends back the response to client. It's like the REST request response pattern that we already have. The second communication pattern is the client streaming pattern. In client streaming patterns, the client writes a sequence of messages and sends them to the server. Once the client finishes writing the message, it waits for the server to read and then return the response back to the client. The third communication pattern is server streaming. It's very like looks like the client's streaming method, but in the server streaming method, client sends a request to server. Servers get the request and starts to read the request and write its response message to the output. And when the response output finishes, it says the client or sends the status code to clients and closes the connection. And the bidirectional streaming is the combination of the client streaming and server streaming communication pattern, where both sides send a sequence of messages using read-write streams. Two streams are completely independent from each other. So client and servers can read and write in whatever order they want. For example, the server can wait to a client to send all its requests and then sends back its response to clients, or it can send the response to client as it gets the request from clients. The important point in client, server, and bidirectional streaming is the message ordering. gRPC guarantees the message ordering and there's no need to do any extra works about the message ordering when we're going to work with the gRPC.
We did have kind of a statement here I wanted to bring up real quick. One of our friends from YouTube is mentioning that you can use C# and protobuf together, but it's not really good because of sharing models. Is that true from your experience, or how do you get around that potential limitation?
I didn't get the first clause of yours, the sentence. Would you please repeat it, David?
Say that one more time, sorry.
Yeah, would you please repeat the question again?
It seems as though this viewer is assuming that you can use C# and protobuf together, but it's not good because you have to share models. So I don't know if that's a misconception, or if you could speak to that a bit.
We're going to talk about it in detail in the next slides, where we're going to talk about managing the proto references. I will clear this question there, if you mind.
Okay.
Okay. Here is this simple proto. As you see, the first line is our protobuf version. There are different proto versions available, proto version 2 and 3, I think. The second line, we can define our custom namespace, which our services will be available under this namespace. Using the service keyword, we can define our services, and using the RPC, we can define our methods. Our methods has the inputs and the outputs, which are also the message. As you see in the message parts, we have, for example, message request with 2 fields, name and last name, or message response, again, with name and last name. The keyword stream for the third and fourth services are really important here. When we put the stream keyword beside the returns, it means that we're going to make a stream in the response channel. I mean, we're going to have a server streaming. When we put the stream in the input parts, we're going to have client streaming. And when we put the stream both in the inputs and output sections, we're going to have a bidirectional streaming. The important point here is the numbers we assign to the fields in the message. They're really important, and they're really important because the whole message are going to be serialized and deserialized using these numbers. They should be unique for each message, of course, and we should take care about this message, take care about these numbers. The problem which arises here is the synchronization of the protofile between client and the server. There is no server, service discovery tools or mechanism available in the gRPC. However, there are some tools in the market which supports the discoverability. But for gRPC itself, it does not have any discoverability approach for us. So the synchronization of the protofiles is an important point we need to think, where the managing proto references comes and play its role. There are various ways where we can manage the protobuf references in projects. We can add the protofile directly to each project. Okay, if we use this approach, we will face with the synchronization problem, where the server proto and the client proto needs to be in sync, because in some cases the breaking chains might cause these some problems for us. So we have synchronization problems when we're adding the files directly to each project. Or we can use code-first approach. This is the point, David, which I told you that I'm going to talk about it. Using the code-first approach is an approach where we write our protofiles in C# using C# classes, using C# data contract or service contracts. And then the compiler converts our C# class to the protofile, and then we can use that. It has one strength here, that we can define this infrastructure in a shared library or in a common library and share it between the server and the client sections. So we solve the synchronization problem by using this approach. But when we are going to define our proto using the C# syntax, we've got the polyglot projects problems. Our approach will not be the language agnostics, because every time we want to interact with the server or clients, the server or client must respect to .NET and must follow the C#, which only a good choice when we are sure that the client and servers both are using the C# and .NET. If, for example, our server is using the Go language and the client is going to use the C# language, of course, using the code-first approach will not work as expected for us. And I think that our friends that told that the writing the proto using C# is not recommended, I think he might notice this point. The third option is adding gRPC service reference to each project. There are some tools such as .NET gRPC tools, or thanks to the Visual Studio, there's add service reference sections where we can publish our proto in a web server. For example, I can put my proto file in an IIS website and then add a service reference to my client and servers to that IIS website. The Visual Studio supports the refresh mechanism where I can refresh the protofile based on the published reference, which this third mechanism is my favorite mechanism to share the protofile between the client and server projects.
Are there any like public repositories or anything set up like that like a common mechanism for publishing protobuf files somewhere at an endpoint or whatever? Because you mentioned earlier there's no discovery, so is there like a standardized mechanism for if not discovery, publishing the protobuf files?
Right, like an open API type thing. Is that kind of what you're referring to, Cam? Something like that?
Exactly. Yeah.
However, I said that there's some tools in the market which provides this discoverability availability to us. At the last slides of my theoretical presentation, I will show you when we're going to test the gRPC services using gRPC URL, there's a mechanism to query the gRPC server and ask the server to describe itself to us. And the server will respond with its services and mistakes, which is very similar to the discoverability approach. But the gRPC itself does not have this mechanism inside it. However, using OpenAPI, as Luis told, using OpenAPI or using WCF, we have the discoverability, we have the WSDL, Web Service Description Language, for the SOAP architecture, SOAP frameworks. But there's not similar approach for the gRPC. However, if you want to read more about the protocol buffers, the Google developers website has a great paper about the protocol buffers, how to write them, the keywords, how to solve the synchronization problems, and so on. I put the link at my slide, and you can refer to this paper. The next point here is the deadlines and cancellations. When we're going to implement client-server communication patterns, of course, there's some cases that we need to cancel our requests, or we need to put deadlines to our requests to prevent the other problems from being created. gRPC have great mechanisms for deadlines and cancellations. Of course, the deadlines allow gRPC clients to specify how long it will wait for a call to complete. When we're talking about deadlines, there is another approach that we might need to think. Suppose that I have a client which calls a gRPC. Let's call it the front-end gRPC1. The client calls the front-end gRPC1, and the front-end gRPC1 again calls the gRPC2. When we're going to define the deadlines, we should have a mechanism to propagate this deadline from gRPC1 to gRPC2. Again, the gRPC itself and the .NET implementation of gRPC has great features to propagation of these deadlines that we define. in our services. When a deadline is exceeded, two kind of exceptions thrown. One for client, the deadline exception, the deadline exceeded exception have been thrown, and the request aborted at the client side. And at the server side, the server call context that cancellation token raised. I mean, there is no exception thrown at the server side when the deadline exceeded. About the deadlines propagation, we have two different mechanisms. We can do the propagations manually by passing the deadline property of the server call context, or we can propagate the deadlines automatically by calling the enable call context propagation in client factory. Just like the deadlines, the cancellations, the cancellation works just like the deadlines. Cancellation allows a gRPC client to cancel long-running calls that are no longer needed. Request can cancel again by setting the call options at cancellation token, or by disposing the caller object. When we dispose the caller objects, we're going to cancel our request. We have these two options, which setting the cancellation token is my favorite mechanisms that we might need to consider when we're going to use the cancellation as deadlines.
Vahid, real quick question. We did have a viewer ask if the deadlines are absolute or additive.
No, there's not any absolution about the deadlines, because as I mentioned, the deadlines and cancellations both are completely two different things. Deadlines allow gRPC clients to specify how long it will wait. Why we set the deadline? Because, for example, I do not want to make a pressure for my server or put my server under pressure. For example, I let the client request to be completed in 10 seconds. And if it exceeds this 10 seconds, I abort the request to manage my resources, both at client side and both at client side and server side. But cancellation is other thing. For example, suppose that I'm on a page, on a web page, and sends my request to get the list of books. But after 5 seconds, 10 seconds, I change my mind and I want to cancel my request. There is no deadline issue here. Me as a user, me as an end user, or me as a client service provider, service consumer, I do not want anymore to get the books. Okay, I can cancel the request. I mean, these two are completely different mechanisms and tools, and I don't believe that the deadlines are absolute. I don't believe that it should be the absolute, because it's really a needed requirements for implementing the services. Of course, for streaming services, server streaming or client streaming services, really needs a deadline and cancellations. Otherwise, a longer running request might chewing up our resources, such as the things that happens in our previous meeting. We need to have deadline cancellation in place. About authentication and authorizations in gRPC, again, thanks to the .NET implementation of gRPC and the great infrastructure provided by the .NET 5, gRPC can be used with ASP.NET Core authentication to associate a user with each code. It means that we do not need to do any extra things for configuring the authentication or authorization for gRPC. The way that we configure the authentication and authorization mechanism in our ASP.NET Core websites or web APIs, but exactly the same way we can configure the authentication and authorization for our gRPC services too. However, there is some small things that we might need to consider when we are working with authentication and authorization in gRPC. One of them is that once authentication has been set up, the user can be accessed in the gRPC service method via the server call context object. And also, gRPC client factory can create clients that sends a bearer token user channel credentials. gRPC supports many other authentication mechanisms, such as certificate mechanisms and the other and the other kinds. I mean, the clause that I write here, that client factory can create clients that sends a bearer token. I do not mean that the gRPC only supports the, for example, JWT authentication. No, gRPC supports the certification, authentication, and other kinds of authentication mechanisms too. The security considerations that we might need to consider working with gRPC. One of them is the using of the transport security layer. It's recommended to use TLS in production environment. However, it's not really related to gRPC. In every production environment where data or where the communication between client and server are vital for us, it's recommended to use the TLS for our communications. The other ones, the exceptions, again, it's the role that we should consider in all our applications. Detailed exception message shouldn't be exposed to the clients in production applications. However, the gRPC by default does not, gRPC in .NET, I mean, does not send back the detailed exception to the clients. And the message size limit is the other thing that we might consider by setting the incoming message size and the outgoing message size in order to prevent the attacks such as the denial of service attacks or the other kinds of attacks that our web server application may suffer from them. Setting message size limits the other points that we should consider.
So real quick, there's actually two questions that I think may be related to security. So one is from Boss Fighter here is, can I use gRPC with desktop apps? And specifically related to security, we had another one here. Sorry, just finding it. That basically was saying that Windows Authentication does not support HTTP2. So would that mean that you can't have gRPC with Windows Authentication?
Yeah, about the using the gRPC with the Windows applications, I'm going to show you that I'm going to connect to my server side using a console application. I mean, there's no problem with communicating between Windows application, console application, or web application, or mobile application with the server side. So we can use the Windows applications plus gRPC, and it might be really helpful. About the Windows authentication, no, gRPC does not support the Windows authentication and Kerberos authentication, I think, and we cannot use these two authentications in the gRPC. It only supports the, if I can remind the certificate authentication mechanisms and the token-based authentication mechanisms. The gRPC supports this kind of authentication. The Windows authentication and Kerberos, I think, are not supported currently in the current .NET implementation of the gRPC. However, I think at the next releases of the .NET gRPC, they might be supported too, but currently, no, they're not supported.
Gotcha. Awesome. Thank you.
Great. The transient fault handling is the other great feature that gRPC provides to us. The transient faults includes a momentary loss of network connectivity, temporary unavailability of a service, or timeout due to server load. During this kind of problems, we might need a mechanism to retry or resend our request back to the server. gRPC supports two kinds of the .NET implementation of the gRPC currently supports two retry strategies, using the retry policy and using the hedging policy, using the hedging mechanism. And the retry policy, it resends the request based on the backup delays, and using the hedging, it's aggressively sending multiple copies of a single request. When we're going to use the hedging mechanism, we should really take care of our request and our server, because it can put a notable pressure on our server. About the test gRPC service with gRPC URL, there are many tools available in the market, but there are two great tools: the gRPC URL command line tools and gRPC UI. which helps us to test our gRPC services without implementing a client side. I mean, the gRPC URL itself plays the client side for me. The gRPC UI is a tool that's built on top of the gRPC URL. gRPC URL, in order to work, it needs to know the protobuf contract of services before it can call them. In order to getting this information, the gRPC reflection on the servers comes and plays its role, and or we can use the specifying the protofile in the command line. I mean, we have two different options to provide the protobuf contract of services to the gRPC URL. One by using the gRPC reflection mechanism, and the other ones by specifying the protofile. Again, there is a great link in the GitHub command line tool for interacting with gRPC. We can go and read about this paper, and it provides really great information how to test our gRPC services. There are many other points that we might need to know about the logging, tracings, metrics, and other things, or the roadmaps or the checklists we need to consider when we are going to migrate from REST to gRPC, or when we are going to migrate from WCF to gRPC services. All these kind of informations are available at the links that I provided at this slide. The gRPC documentation at gRPC.io provides you great insight about the gRPC architecture. The gRPC gateway has a great description about the gRPC ecosystem itself. Again, and like ever, the Microsoft documents, I mean, the great points of one of the great points of Microsoft is its documentations. Introduction to gRPC and .NET has a great and great papers and contents about using the gRPC. By going to the github.com, the gRPC source are available there. You can view the source code of the gRPC, the .NET implementation of gRPC, logging gRPC requests using Serilog at the Ferreira's sites, and the Steve Gordon's website provides the gRPC client factory. That's really important in communicating between client and servers. In order to contact me, again, you can follow me on Twitter using @sign_jinget, or my LinkedIn, GitHub, or email address. Okay, sorry for my speed, because I like to cover some theoretical points, and then we're going to working with codes.
Sure.
Here I have two source codes, with one of them is for my gRPC client side, and the other is my gRPC server side. As you take a look at my protos, for example, my sample proto, I have 4 different. Let's increase the.
Yeah, I was going to ask if you could zoom in a bit. Thank you.
Okay. Here I have defined my services. I have my messages, which are defined here. The message can be put together. For example, my country collection response has a field named countries, which is type of country response. Country response itself is a message with its fields available here. And the other proto file, for example, for authentication mechanism, I have login and restricted source services here with their messages available. All are here.
Real quick, Vahid, one thing I've noticed is, like, on line 12 and 13, for example, on the login request, when it says string username, there's an assignment of =1, and then on line 13 =2. What is that for? Is that like the ordinal, like the location or whatever in the binary serialization? Like what is that?
Yeah, in the serialization mechanism starts serializing data using these numbers. In fact, when we're talking about the binary serialization space, or LAN, and we say that the binary the gRPC binary serialization mechanism produces a light-weighted output, it's because it's replaced the username with 1, or it replaces the password with number 2 when it's going to serialize our data. This is why I said that. This is why we need to put our protos at the server side and client side in synchronization states, because if at server side I have username equal to 1, and at the client side I put the
You have to zoom in here too, but I think I understand now, right? So that's the
if I put
alignment.
the username here too, the data will be I will not able to deserialize the data as it. I might have face some problems.
Now, do those have to be numeric, or can they be, like short strings, or how does that work?
As far as I know, they should be numbers and they should be numerical values. And I didn't anywhere that they put the character strings, for example. As far as I know, it should be numerical values.
So that, okay. I guess that goes back to one of those questions from earlier. Would it be possible to share a class library that defines the proto definitions, if you will, right? Basically the shapes of those requests and responses that is shared and consumed by both the server and the client?
Yeah, it's possible to define the shared class library when we're going to let's say that at the Microsoft site, there's a great explanation of this problem. We can put the data contract and service contract attributes over our service and the properties. Plus, there is an ordering property that we can put. There's an ordering attribute that we can put on top of our properties. That ordering values will translate it to these numerical values. We can share, again, I said that we can have a shared infrastructure or shared class library between server and clients and implement our proto files in that shared class library using C# class, using C# language, not using the proto syntax.
Got it.
And after that, it will translate into proto on the fly.
Got it.
Okay. After that, in order to start using the gRPC, we need to enable the gRPC using the services that add gRPC method at our configure services. Here we can set our max receive message size or max send message size limitations that I showed, or we can set these limitations for specific services by defining add service options. For example, I'm going to say that for sample services or for sample service, I'm going to define max receive message size equal to 1 byte, or of course 1 byte is too short, or I'm going to set the max send size equal to 1. Totally, if I'm going to enable gRPC in my application, I should use the service.add gRPC method here. As you see, I'm going to configure the authentication mechanism. It's the same as the way we configure the authentication mechanism in our web API projects or in our .NET Core applications before. So let's close this. Or the authorization middleware here that is the same as we use in our previous .NET Core web API applications. By putting the add gRPC reflection, we're going to enable the reflection, which is going to use by the gRPC URL, which supports the testing mechanism of our services. So putting the add gRPC reflection here is required for the gRPC URL command line tools. At the configure section, the important part is setting or mapping the gRPC service. If I, for example, comment this line, it means that I'm not going to publish reflection service as a gRPC service. So any request which target the reflection service will be rejected. So by mapping the gRPC service, I'm going to publish these services to the clients, and the map gRPC reflection service that should be used in development environment. Let's start the gRPC server and take a look at the outputs provided for us. As you see at the console, it says that our gRPC now listening on HTTPS port 501, and I can open PowerShell here. I've downloaded the gRPC URL tools here. I'm going to that.
Can you zoom in on your terminal or your PowerShell?
No, it's not. You cannot use it on your terminal. Okay, I'm going to say the gRPC URL at the local host port 5001. Please describe it for me. It describes the output for me and says that I have a service named sample, and samples have 5 RPC methods I can call, or I have an authenticate methods here with 3 methods, or the reflection service method with 1 method here. And I can directly call my method here using the service name, for example, reflection service slash my method name, for example, reflection. I'm going to call this method and hit the enter. Okay, as I say, it connected to the server and returned the response for me, message hello reflection. If I switch to the server and go to my service implementation, the reflection service, I have a service called reflection, which going to return message hello reflection data to me. So without having a client-side implementation for my gRPC, I test my gRPC using the gRPC tool. Let's close this PowerShell and start my client side, or let's take a look at the client-side implementation tool. I have a class here, let's call gRPC helper. At gRPC helper, I have defined the channel, and also I've defined the channel and also my client, which I'm going to target it. And I have different kinds of methods. For example, the login method, which is going to send a request to the login method at the server side and sends the username and password values, and then get the response headers using the get trailers and read the header value. Or I have the get restricted resource method, which first tries to log me into the server and then sends other requests to the restricted source. Both of these two methods are unary implementation of the gRPC. We have other kind of services here. For example, the server streaming method. I'm going to send a server streaming request to the server. As I told you, when we're going to use the server streaming mechanism, the client sends 1 request to the server, and server starts sending a stream of response. That you see here, the client sends 1 request, and server will stream the response. But for the client streaming sample, client starts to sending a stream of requests. Here we can see it. For example, I have a for loop here, which sends different requests to the server and waits for 1 second and then sends the other message to the server. After clients completed the request, it informs the server by calling the complete async method and waits for the server to send back the response. And about the bidirectional streaming, if you take a look at this implementation, it's really likes the server streaming plus client streaming, and it's really straightforward here. Let's start my console application here. I have a program CS file here, which first calls the get restricted resource, which first tries to log me into the system, then pass my token to the server. As you see here, I have the get restricted resource. It first logged me into the system, then read the authorization header and sends the authorization header back to the server and call the restricted source async. The restricted source async, on the other hand, at server side, is going to return the welcome and the logged in user's name, which I can see it here, that says welcome Vahid. I have 4 options for unary, server streaming, client streaming, bidirectional streaming. Let's start with the unary service call. Client sends 1 request to server, and server returns the response to the client, just same as the REST APIs we had already. For the server streaming, as you see, there's a request timestamp here plus a response timestamp here. If we take a look at this request and response timestamps, we notice that all the requests have the same time span, which means the client sends one request to the server, but the response has different time spans. For example, this received at the 11 seconds, this is 13 seconds, and the other 15, and the other. This means that the server starts streaming the response to client. And for the client streaming, if we take the client streaming section, as you see, it might take a period because clients start sending a stream of requests to servers. Again, takes a look at the request and response timestamps. Request here, it's for 51st seconds, the other for 52nd, 53rd, and the other. But the response timestamps are almost same, which shows that the client starts streaming the request to the server, and the server gets the request and return the response. And for the bidirectional streaming, as you see, client sends request to server, and at the same time, server returns a response. I told you that using bidirectional streaming, server can wait for client to send all its requests and then send back its response, or it can send back its response while the client is streaming the request. At these implementations, I've implemented the request and response, which are going to handle at the same time. The final point that we should take a look is implementation of the these communication protocols. The unary communication protocol is really simple, and there is not any special case in implementing the unary sample. For server streaming sample, as you see, the method waits for the cancellation token. It means that unless the user cancel the connections, server get the request and start processing the request and write its response to the response stream, and then send this response stream back to the client. For the client streaming, if you see, there is the asynchronized for each loop here, which is going to read the request streams as they get to the server. Server get each stream and start processing the request and send back and wait for clients to close the connection. And when the connection is closed and the request streams ended, it sends back the responses back to the clients. And for the bidirectional streaming, is again the combination of these two implementation. The server starts reading the request streams at the same time. It's write the reply at the response stream and sends back to the A2C clients. About the cancellation and deadlines, if I want to show you, for example, here I've defined the cancellation token, and I can cancel the my request. Let's uncomment section. I told my client if the I value exceeds 100, cancel the request. So the server is running, and I need to. Oh, there is an error here. Okay.
Well, we are reaching our time box, so this is...
It's end of the show. I showed the cancellation mechanism. It's the client streaming. And as you see, the request canceled and the connection aborted. I hope you enjoyed this presentation, and I do my best to give you a simple insight about the gRPC and the .NET implementation of gRPC. And again, I told you, please, when deciding to choose gRPC for your technologies, please think about the requirements, your costs, and your benefits that you are seeking. I hope you enjoyed.
Yeah, this was great. Yeah, we do have a couple questions real quick there. Some of our viewers are really curious about the slide deck, if you're willing to share that, because there's some links, and then also
and the source
code.
Yeah, all the slides, the gRPC URL and the source are available at my GitHub page. They can refer to my GitHub account and clone the source codes from my GitHub account. All are currently at my GitHub at this address, github.com/Vahid Farahmandian at the Jinget gRPC. There's this source for the server and client and the presentation file, and plus the gRPC command line tools. All are available at this URL.
Awesome. So I want to thank you. I want to thank you again very much for joining us a second time, Vahid. You're one of our repeat guests. We love having you on. You have very detailed, excellent presentations. And I want to thank all of our viewers for watching the .NET Docs show. .NET Docs show. I should enunciate. Check out our show recordings, our upcoming topics, and more at .NETDocs.dev. Tune in next week when we have absolutely no idea what we're doing. Seriously, that we are TBD for next week. So we probably will be on the air as usual, but we have no idea what we're doing. So tune in next week. It's a mystery show. Awesome. And with that, everyone have a good week.
Bye, friends.
Thanks.